Welcome back, everyone. Ready for another deep dive?
Always.
Today, we're taking on something, well, massive. Black holes. Those regions of space-time where gravity is so strong, nothing, not even light, can escape.
Exactly. And even though they sound, kind of like science fiction.
They are very real. But what's really fascinating, at least to me, is what happens inside a black hole.
Yeah, it's a big question. What's going on beyond that event horizon?
The point of no return, right?
Right. So to tackle this, scientists are turning to something that sounds almost as mysterious as black holes themselves.
Let me guess, quantum computing.
You got it. It's this cutting-edge tech that uses quantum mechanics to do these mind-blowing calculations that would be impossible for regular computers.
Okay, I have to admit, quantum computers still sound a bit like science fiction to me.
I get it.
So how are they being used to study these, massive and distant objects like black holes?
Well, researchers like Enrico Rinaldi at the University of Michigan, they're building what are called quantum matrix models.
Quantum matrix models.
Yeah. Basically simplified representations of a black hole's quantum system. And they're using these models to simulate how particles behave in those super strong gravitational conditions inside a black hole.
So instead of looking at a real black hole, which is, like we said, impossible, they're running virtual experiments.
Precisely. And this is allowing them to explore some really wild concepts. Like, have you heard of the holographic principle?
A holographic principle?
Yeah, it suggests that everything we need to know about a black hole, like all the information that falls into it, could actually be encoded on its surface.
Wait, really?
Yep, like a hologram.
So you're saying the entire 3D interior of a black hole could be represented on its 2D surface? Like a cosmic projection.
It sounds crazy, but it's gaining a lot of traction in theoretical physics. And this is where understanding the ground state of a black hole is key.
Ground state? What's that?
Think of it like a black hole's lowest energy state, its most stable configuration.
Ah, okay. So finding this ground state is like discovering the black hole's blueprint, the starting point for everything.
Exactly. But the challenge is finding this ground state is like, I don't know, finding a specific grain of sand on a beach.
That sounds incredibly difficult.
It is. There are so many possible states, and that's where quantum computers come in. Unlike our everyday computers that process information bit by bit, quantum computers can explore tons of possibilities at the same time, thanks to something called superposition.
So quantum computers are like superpowered explorers.
Exactly. They're like, imagine a team of detectives all working a case at once.
Okay, I could see how that would be useful.
Right. And this has allowed researchers to figure out the ground state energy of their simulated black holes with really impressive accuracy. And that energy, it holds clues about the information on that black hole's surface.
Okay, so the ground state energy, it's like a fingerprint. It tells us something about the black hole's structure and the information it contains.
Right.
But how do they actually find this ground state? What does that process even look like?
Well, this is where things get really interesting. They use quantum circuits, which are basically sequences of operations on these things called qubits. And get this, they've compared these quantum circuits to musical compositions.
Wait, music? Now we're talking about black holes or Beethoven? I have to admit that sounds a bit far-fetched.
I know it sounds strange, but stick with me. Imagine each qubit in the circuit is like a note on a score. And the quantum gates, those operations they do, are like instructions for how to arrange those notes into a melody.
Okay, so they're composing music with quantum computers.
Kind of. They even use a technique called shaking, where they adjust those quantum gates to find the correct ground state.
So like a composer experimenting with different notes and arrangements.
Yes, they're trying to find the perfect tune, the one that represents the black hole's ground state.
That's an amazing way to think about it.
Yeah.
But what does this musical analogy tell us about how complex this system is?
That's a great question, and it really highlights just how incredibly complex a black hole's quantum system is. Each of those qubits, they're like a tiny piece of the puzzle, and those quantum gates, they're like this intricate set of rules for how all the pieces fit together.
Okay, yeah, I'm starting to see it.
So finding that ground state, that perfect melody, it tells us something really fundamental about the black hole, its structure, and how it connects to this crazy holographic principle.
It's like those quantum circuits are revealing a hidden symphony, but instead of sound, it's the dance of these quantum particles.
Exactly. And by listening to that music through simulations, scientists are getting insights we've never had before.
But let's be real, most of us aren't quantum physicists. What are the big takeaways even someone like me can understand? Why should we care about this ground state of a black hole?
That's a good point. The details can get pretty complicated, but the implications are huge. By studying black holes, especially with these new quantum tools, we're not just, satisfying our curiosity.
Right.
We're probing the fundamental laws of the universe, pushing the limits of what we understand about gravity, quantum mechanics, even the nature of reality itself.
So black holes are like these ultimate laboratories, places where we can test our biggest theories.
Exactly. The more we learn about them, the closer we get to answering those big questions, the ones humans have always asked. Where did we come from? What is time? What's going to happen to the universe? Black holes might hold the key.
But is this holographic principle, is that something everyone agrees on? Are there other ideas about where information goes in a black hole?
It's definitely a compelling idea, but like all scientific theories, it's still being debated. There are other proposals out there, like maybe the information gets scrambled inside a black hole, making it practically impossible to get back, even if it's not actually destroyed. But the great thing about science is it's always evolving. As we gather more data, build better tools like those quantum simulations, our understanding grows.
What about the limitations of these models? Are there things about black holes we just can't simulate yet, even with quantum computers?
That's another good question, and it shows that we're still in the early stages of using these quantum computers to study black holes. Right now, those models are simplified versions of the real thing. We're limited by how many qubits we can control, how complex the algorithms can be, and even our understanding of quantum gravity, which is still a work in progress.
It's a lot more work to do, but it sounds like we're on the verge of some major discoveries. This research, it's been called groundbreaking, revolutionary. But what does that actually mean? What's the impact beyond just understanding black holes?
Well, the things we learn about black holes, they could have effects across many different fields, like a deeper understanding of quantum gravity that could change how we think about the Big Bang, the very early universe. It could even lead to new technologies we can't even imagine yet.
You mentioned these models being simplified. Some people might say that using quantum computers to simulate something as mind-blowingly complex as a black hole, it's just too limited. What would you say to that?
It's true that any model is a simplification, but that's how science works. We start with the best tools and the best knowledge we have, and then we build from there. These quantum simulations, even with their limitations, they're giving us a glimpse into things we could never see before. They're letting us test our theories in completely new ways.
This has been incredible, peeling back the layers of mysteries surrounding black holes. Quantum circuits, musical analogies. It's amazing how scientists are using this cutting-edge tech to explore the universe's deepest secrets. And I feel like we're just getting started.
Oh, absolutely. As quantum computing gets even better, so will our ability to simulate and understand these fascinating objects. Who knows what other amazing discoveries are waiting for us as we keep exploring the universe with these powerful tools.
It's like we've had this crash course in cosmology and quantum physics,
Yeah,
all to try to understand these cosmic enigmas.
right.
But before we wrap up, where do we even go from here? What are the next steps?
Well, that's the really exciting thing. This is just the start of using quantum computers to explore the universe.
Okay.
As this tech gets better and we can use more qubits, we can build much more complex models. Imagine being able to simulate a black hole being born or two galaxies crashing together.
Whoa.
Yeah, with incredible detail.
So we could actually see things that have never been observed, like recreate the early universe.
Pretty much. It would be like having a time machine powered by quantum mechanics. We can test theories about the Big Bang, about dark matter, maybe even figure out the nature of time itself.
Wow. It's mind-blowing to even think about the possibilities. But beyond these big questions, are there any, practical uses for this research?
Scientists are definitely exploring that. It's still early, but we're already seeing the principles of quantum computing being used in things like materials science, drug discovery, even cryptography.
Many different areas.
Right. As we understand quantum systems better, especially by studying black holes, who knows what other amazing technologies we'll come up with.
This deep dive has really changed how I see black holes
Yeah.
and the potential of quantum computing. But it also makes you realize how much we still don't know.
Oh, definitely.
There's this sense of wonder and mystery that, I don't know, I find it pretty inspiring.
I agree. The universe is full of surprises, and black holes are like some of the most fascinating puzzles out there. Every time we learn something new, it leads to more questions, driving us to explore further.
Well said. I think we've reached the event horizon of our own deep dive into black holes and quantum computing.
Yeah.
It's been a great journey, and I hope everyone listening has enjoyed it as much as we have.
Absolutely. And if you're feeling curious, we encourage you to keep digging into this amazing topic. There's so much out there to learn. Maybe you'll be the one to make the next big discovery.
That's right. Don't forget to like and subscribe for more deep dives into the world of knowledge. And until next time, keep exploring.